Hello everyone and welcome to Ask AstronEra, in which initiative I talk about the astronomical questions which I get asked the most. I've been working in the field since past 8 years now, and I get asked a lot of questions about astronomy and they're really interesting. So I thought that during this quarantine period, if I could answer these questions online, maybe a lot of people get to understand their answers, because these are very general questions. If you have any more topics in your head, if you have any questions in astronomy, do post them in the comments so that for the next Ask AstronEra session, I will get to answer the questions that you actually have in mind. Also, while during this session, if you have any questions about whatever I am talking about, you can just post them in the live chat. I'm extremely sorry about the last time. I couldn't see the live chat and I couldn't see that some of you had posted your questions, but I hope this time everything works out smooth and I'll be able to see your questions and answer them. If anything goes wrong, please post your questions in the comment box, even about the same topic, and I'll make sure that you see the answers, that you get the answers. Also, I have another announcement. Tomorrow evening on Instagram, we are going to have a live session with Bailey, and she is going to talk about the future of space, navigating the space industry. So here you can see her poster. You can go on Instagram. Our channel is AstronEra. So you can search AstronEra on Instagram, follow us, and tomorrow join the session with Bailey. It's going to be an interesting session. So I hope you guys join in tomorrow as well. Now, let's start with our today's session with an amazing topic about black holes. This is the question that I guess get asked a lot, that what will happen if I fell inside of the black hole? So of course, to answer this question, we have to figure out what exactly a black hole is. And black hole is kind of the concept that I was personally wondering about since very young age. I think I was just in 6th grade. I was like 11, 12 years old, and I came across the concept of black hole. And since then, my interest in astronomy has been growing. And I also had an opportunity to join talk about black hole by Dr. who's our mentor now, and he was kind enough to answer all the questions that people had, and even he answered one of the stupidest question that I had asked. I hope you guys are looking forward to knowing what will happen to you if you fell into black hole. But before that, let's know how the black holes are formed first, right? So to tell you how the black holes are formed, I have to explain to you a little bit about the stars, because these black holes are finally the remnant of stars. It's basically a dead star. So black holes are formed when a supermassive star ends its life, as it completely burns out its fuel, which is made up of hydrogen and helium. So when this hydrogen and helium burns off in a star and there is no more energy provider to the star, the shells of the star kind of get, they get blown off in the space, and what is remaining to the star, like its core, it kind of collapses onto each other, and there's lots of gravity over there. So that's how a stellar black hole kind of is formed. So the core of the star collapses under its own weight to form a black hole, basically. And there are 3 types of black holes. So this one that I told you about, we have observed such black holes and they do exist. So it's been comparatively easier for us to study about them and know how they have evolved. So these are called the stellar black holes. There are also supermassive black holes, which are mostly found at the center of the galaxies. So these black holes are kind of giving all the energy for the galaxy to keep all the stars in the galaxy together. We don't really know how they must have formed, but the study suggests that they might have formed in the beginning of the universe from the first generation of the stars, which were insanely massive, more massive than we can even imagine, and more massive than any star that exists right now. So of course you can imagine why they are called the supermassive black holes, and they power the entire galaxy and keep it together. Yes, we also have a black hole in the center of our own galaxy, the Milky Way. It is called as Sagittarius A star. And we have observed through the astronomical telescopes that some stars were going around it, and when they come closer to that point in the middle where there is a black hole, they change their orbit a little bit and they kind of swoop across that a little bit faster. So that's how we are sure that there is black hole in the center of our galaxy. And the study suggests that there are lots of black holes in the center of other galaxies as well. So that's the second type of black hole. The third type of black hole could be really small, like that of the size of an atom, and it would have it would have mass of as much as a big mountain. So in like very tiny dot, like just an atom, there would be so much of stuff packed in it, and that would generate lots of gravity, and that's why it's a black hole. And we don't really know how those are formed. Of course, we only know that the black holes are formed with the explosion of stars. They are the remnants of the stars. So yeah, moving on. What exactly is black hole? I mean, the name suggests that it's a hole which is completely black. Then how do we see it? So we see it with the gravitational lensing a little bit. So we don't really see the black hole, but we see the stars and galaxy beyond that, or kind of around it, and they get bent. Their light kind of gets bent, which we call as gravitational lensing. And that's why we can kind of see that there is like a black hole, like a circle in the middle, around which lots of other stars and everything around is kind of being bent. So basically, black hole is a region in space where force of gravity is so strong that not even the light can escape from it. And this happens because of the escape velocity. So the escape velocity of the black hole exceeds the speed of light. The escape velocity of the Earth is 11.19 kilometers per second, and the speed of light is about 2 lakh kilometers per second. So you can imagine how massive the escape velocity of the black hole would be. To tell you a little bit about escape velocity, you can understand it by this example. If you just throw a ball in the air, the ball will come back, right? But if you attach like something big to the ball, which would throw it even faster in the air, it might reach to the point where it will not come back. You have to give it as much force. So this force is called as escape velocity. So if you throw the ball in space from the Earth with 11.19 kilometers per second of speed, it will not come back, and that's the escape velocity of the Earth. So if you are standing on the black hole, which is completely impossible, and you throw a ball in space, which is again completely impossible, but just to imagine a little bit, if that happens, it will take you the speed of light to throw the ball in the space for it to come back. Actually, the speed more than that. So, you understand how massive the gravitational field is there in the black hole, and it has escape velocity of the speed of light, or even more than that. So according to Einstein, this happens because of the wrapped space-time around it. So again, we have to go into much depth to understand the space-time stuff, but let's stay on the surface about our main questions. What is inside the black hole and what happens if you kind of fall in it? So the short answer of what is inside of the black hole, behold, we don't really know. Yeah, that's right. We actually don't know what is inside of the black hole, because as I told you that the space-time is being wrapped around it, and everything about physics kind of goes crazy in the black hole. So, black holes have some sort of boundary up to which we have been able to study them. So this boundary is something that we call as event horizon, beyond which we haven't been able to observe, and we don't know what happens beyond this, and physics goes crazy beyond this event horizon. So the space-time starts getting wrapped at this event horizon, and it kind of also gets twisted beyond our understanding further than that. So according to the theories within a black hole, there is something that we call as singularity. So this singularity is where everything that passes the event horizon gets crushed into. So singularity is kind of the core of the black hole. Okay, so if you were to approach the event horizon and kind of try to go in the black hole, this is what will happen. You would kind of start falling in the black hole, and there would be no escape after you pass the event horizon. So that's because the tidal forces will become too strong, and it will become too fast for you, like you'll be traveling so fast. So the tidal forces of course become too strong when you're traveling that fast, and it kind of is impossible for us to survive all this. So this is not just it, like why it would be impossible for us to survive is when we just pass the event horizon, or even before we pass the event horizon, you will kind of get stretched like a spaghetti. You'll be spaghettified, and yes, that's a term, that's a scientific term, that you'll get spaghettified. So each atom in your body would be stretched, and if your feet are towards the black hole, the toes would have more gravitational force than your head, so you'll be stretched so much atom by atom. It'll be so painful, it'll be such a painful death, but it'll happen in a flash. So it is impossible physically to peep inside a black hole, to get inside a black hole and to see what's happening in there. Also, another interesting phenomena would happen, it's that if you look towards the singularity, like if you look towards the black hole, you will see everything that's fallen into it before, because you'll be traveling towards it very, very fast, more than the speed of light, and the time would be going really, really slow for you. So that's why you'll see everything that's ever fallen into black hole before you. And if you look upwards, like if you try to look away from the black hole, you will actually see the future. You will see everything that will fall in the black hole in the future. So I think that's really interesting. So the time dilation kind of is very interesting phenomena about the black hole. We also discussed it in the last session that as the gravity is stronger, the time would get slower over there. So yeah, that's basically about the black holes that I wanted to share with you today. Now let's go through some questions today. Fortunately, I'm able to see the questions, so I'll answer them one by one, and you can keep posting them because this is such an interesting topic. So I have a question from Kiran Kulkarni. He's asking, is our sun going to become a black hole? Well, actually, for a star to become a black hole, it has to have at least 10 times more mass than of the sun. I'd say even 30 times more mass than that of the sun. So the smaller stars, the sun is kind of a small star, so the death of sun is going to be just a supernova, and it will not even be that spectacular because it's a really small star, and it will end up as a white dwarf. So if you guys want to know more about the life of star, of course I can blabber about it, but we have already made a course about the life of star on AstronEra.org. So you can log into that course and you can understand everything about the star, right from how it is born and how it ends up as black hole or supernova or neutron star or white dwarf or whatever. So you can check that out. But yeah, the sun is not going to become a black hole. It will end up just like a mild white dwarf and cease to exist at all. The next question is by Sanika J. Is the black hole spherical? Yes, because the gravity kind of is from all the directions. So all the direction is basically a sphere. So that's why black hole will always be spherical in shape. Well, okay, I just explained the answer for Kiran. We have another question by Sandeep Nirgude. To go into other galaxy, we have to pass a black hole, as the black hole is also in the center of our galaxy. Well, no. So imagine this. I have this used plate over here. So if this is our galaxy, imagine that the sun is kind of towards this side. So this is the center of galaxy and our sun is kind of towards the edge. So the other galaxy could be on this side as well. So you don't always need to cross the center and you can just travel from over here to the other galaxy. But it would of course take thousands of light years for you to travel like that. And also, if you go inside of the black hole, there is never coming back. You cannot ever escape a black hole, because I told you about the escape velocity. If you want to escape black hole, you'll have to travel with the speed more than that of the light, which is 2 lakh kilometers per second. So it's physically impossible. You must have seen that in Interstellar, he goes inside of the black hole and then he comes out, he's in another galaxy, and then he comes out of that black hole to our own Saturn in our solar system. But no, that is not possible, at least with the knowledge that we have right now. We cannot cross a black hole. We cannot manage to pass the event horizon, and even if we did, there is never coming back or going out of the black hole at all, unless there is something like white hole exists. So this is kind of a theory. Let me explain it a little bit before I move on to more questions. So white hole is like a theory which is completely against that of a black hole, and it said that white hole might kind of vomit everything that the black hole has gulped. But it is just a theory, and we wouldn't even know how that would form, right? Like the black holes are formed because of the death of the star, but how would white holes form? There's no physical explanation for that. Okay, so yeah, Sandeep, to summarize the answer of your question, that we don't have to cross the center of the galaxy to go to other galaxies, and if we get inside of the black hole, we cannot ever come out. Okay, so Sarth is asking, sun will be, okay, it's just an explanation. Sun will be a dwarf, not a black hole. The sun isn't massive enough to be a black hole. That's true. I just explained about that a little bit. Nirmal Gupta is saying, what is the difference and similarities between quasar and black hole? Well, quasars and black hole, I'm not quite sure. Both of them are the stages of stars in their different stages of their lives. So yeah, I'm sorry, I'm not really sure about what exactly is the difference, other than the stars which form the quasar and the black hole might be different in their masses and their sizes, and they might be at different stages of their life. But yeah, I mean, the quasars might be a stage of star before the black hole is formed. I'm not really sure. I'm sorry about that, Nirmal. Okay, another question by Sandeep Nirgude. Why the stars around the black hole, why they don't go inside of the black hole? Well, actually, in 2014, we did observe a star going inside of the black hole, and that's how we got to know that it actually gets spaghettified. So yeah, I mean, if the star reaches close enough to the black hole, it is close enough at the event horizon that it cannot escape the pull of black hole, then it will go inside of it. If not, it can just, you know, go around. It's like, you know, on the earth, if you imagine that the missions that we send in space, they orbit the earth a little bit and then they slowly go away with this orbit and move their path to a different planet or the moon. So similarly, this kind of again goes to a little bit about the escape velocity. So not all the stars would kind of go into the black hole, but if they are close enough, they would. But some lucky stars are further away and they can just go around it a little bit faster, which is also something that we have observed about Sagittarius A star. Okay, so we have another question from Sarth. In the future, the Andromeda galaxy and our galaxy will collide. What will happen to the black hole at the center of the two galaxies? Will they collide or anything else will happen? So, interesting question. Actually, I do think about two galaxies colliding, but I never really thought about the black hole. So it's really stimulating discussion. Alright, so when we say that the galaxies are going to collide, they are not going to collide like both are coming from the two sides and whoosh. So what's going to happen is that they will go across each other a little bit, they'll orbit each other a little bit, and then they'll merge. So for an outsider, like if you're far away from the galaxy, you will see that this is kind of a peaceful process compared to the massive collision. So I think what would happen to the black holes would be that basically they will get merged eventually, because these two black holes would be really strong entities in both of these galaxies. So they are basically just going to come together and merge to form a bigger black hole to support the bigger galaxy that would be formed out of Andromeda and the Milky Way. So yeah, I think that's the answer. Okay, I have another question by Nirmal Gupta. Why gravity is called weakest force if the gravity of black hole can tear the star or destroy the strong nuclear force? It's called the weakest force. Why is that? I'm sorry, Nirmal, today I don't have the answers of your question. I haven't really thought about it, but I'll surely, research about this a little bit and get back to you. But I think there are even more stronger things that we need to discover. We haven't discovered yet more than gravity. That might be it. But yeah, the strongest gravitational pull is what the black holes have. I'm really sorry, Nirmal, I couldn't answer even this question by you. I will try my best to research about it and get back to you about this for sure. I'm really sorry. Alright then, unless and until you guys have more questions, I'll wait a little bit if you have more questions, or otherwise we will call it a session. Before that, again, a reminder, from 6th of September, we are going to have sessions by Dr. Reut Abramovich from Israel. She is an astrobiologist, and our course is going to be about the life in the universe and the astrobiology. So it's really interesting. The session has already been scheduled, and I will also post the link of the session on 6th of September in the description of this video or in the comments. So you can maybe go to that and see the course, see the video for 6th of September. So on 6th of September, we are going to have our first lecture with Dr. Reut, which is the beginning of life, and it is going to go on for next 4 sessions. So these sessions are going to be there every Sunday at 6 p.m. and do join in, because if you do all the lectures, you will also get a completion certificate. So I hope you guys have enjoyed this talk. Nimish Age has answered some question. Nimish is our team member, so he has answered the question about quasars and the other question about black hole. So you might want to check that out. Thank you, Nimish, for that. So I'll see you guys. Don't forget about tomorrow's session on Instagram. This was fun talking about black hole. Do let me know what else you would like me to talk about, and I'll definitely come up with an amazing Ask AstronEra episode next Saturday at 5 p.m. So I'll see you guys. Clear skies.